Let's try to make it quite interesting to analyze this. We'll try to answer some questions. Okay, so first question is this, sir. Every day we are typing a lot of URLs, right? We are typing URLs. I've been giving you google.com examples like that. But then let me try asking you some questions and let's see, whether we can find out answers. So, sir, why are we typing like this, right? Say vit.ac.in. Okay, there's an HTTP protocol, right? I can't remember the IPs and all that. Fine, I have this. Why are so many dots there, sir? Why can't it be just my website, Jai Vignesh? Okay, so that's my first question to you. Okay, second is, okay, now what is this in? There's something called com. Anything you're aware of different domain types? Anyone? What are all?
.edu, .org,
Edu, .ac. What else?
.org.
Org, right? How many such domain types you're aware of? Now, what is all that? Okay, so that's one thing. Why do you need dots? The next question to you is this: how many dots can I have? Can anyone tell me what is the largest domain name that you can have ideally? You can also Google that and try to find out what is the largest domain name that I can have, right? Ultimately, humans cannot remember IP addresses. All these are servers which are hosting services, whether it is a website, whether it is a mail server, everything IP address, right? All these protocols, whether HTTP or SMTP, can only understand IP address. But I, as an end user, cannot remember the IP address of the servers. So I need a service which will try to map, okay, you want this domain name mapped to this service, get it. Fine. But then we'll try to associate and find out what is the IP address. You don't worry, user. I will take care of that. That's what DNS is going to do for you. But the question now is, why are we, how many such dots I can have? Why do you need dots? Can't it be a flat name? Why should it be like this? Like how you have IP address, which is an hierarchical address where dots coming in to represent that. Here also names, we have dots, right? So can't I have, a flat name? What's the drawback of that? So these are some things we'll try to understand. But then how many dots you can have is a question that I want you to look at it. And what is the length of, right, or the max length that I can have for each of these labels, vit.ac. These are just things. Say, let's look at IIT's websites. Now, every campus of IIT, in fact, VIT also has this now, ap.vit.ac.in, right, bhopal.vit, all that it has, right? But then there are certain parts which are fixed, vit.ac.in is fixed, but then you prefix with your own names depending upon your location of where your web server is, right? Say, IIT, if you look at, say, IIT Madras, right, for every department, they have their own domain name. Say, for example, iityum.ac.in, you take the CS department. So the CSE department has hosted its website and it's running in a server. And they have created a domain name, which is csc.iit, I'm sorry, iitm.ac.in. Now, similarly, you take IIT Delhi, right? iidd.ac.in, csc.iit.ac.in, right? So these are completely different IPs. But then if you look at, right, there are some parts where there are some similarity, but the entire domain name, as you see, is quite unique. So now it's like decentralizing, right? So we'll understand how many such dots you can have, what is the length of these labels for each of this rupees that you have, and what is all these domain types. These are something which we'll try to inculcate. And how does the name resolution happens to find out the IP address? That's what we're going to look at. I hope I have triggered your interest to some extent. But yeah, there's a vast of things, but we will try to look at from a very fundamental things here. So as told, I want, all these inspirations are all from your previous era of what we had. We all use telephone networks, right? Landline phones. I can't, remember all the telephone numbers. So we had mapping of the names to that number and we were searching that. So telephone directory was there, and then our smartphones basically tries to do the lookup, right? So we prefer names instead of numeric address. But then we need a directory system to map the name to an address. Okay, so that's what we need to do. But then if you have a database, a central database, which holds all the global domain names and the IPs, And that central directory system, say for example, right, if you maintain there, everyone, any client wants to get to know what's the IP address of a domain name, go hits this central directory system. What if that central directory system collapses? The entire internet will collapse, right? So we are not going to look at one centralized directory system where we are going to refer this database to get the IP given a domain name, right? We are instead going to distribute the information among many computers, many DNS servers, which are hosting this part of the information. And you can query your nearest DNS server to get what is the IP for a given domain name. That's the idea that we're going to do. So any host who wants to find out what's the domain name or what's the IP for a domain name has to contact the closest computer which is holding that information, or which is hosting that service. And that service, we call it as the DNS service, and the program or the server which is hosting that service is a DNS server. Okay, so let's now look at how DNS works. Now, again, this I've been talking about application layer protocols, and I've been using this word called client server paradigm or client server protocol, right? So what does it mean now? As a client, you as an end user can't remember IP address, right? So you want to know what is the corresponding IP back to the domain name. So now it is not just you as an end user want it. Every other application layer protocol, which is hosting, say for example, you're sending an email and you want to send it to me, jayvignesh.t@vat.ac.in, right? So this email needs to be delivered to my mailbox, right? But then SMTP, say the protocol at your end, client end, does not know what is vat.ac.in. It wants to know what is the IP address of the mail server. So SMTP will get the help of the DNS client program that's running on your, it's a service that's running on your system. And the DNS client in turn tries to use the protocol, right, based on DNS, which will send a query. So ideally, what I'm trying to say is whether it is SMTP, you're sending an email, or whether you're typing an URL, which is HTTP service, which you already looked at, right? Now, HTTP can't understand what the domain name is. So HTTP or SMTP or whatever it is will get the help of the DNS client. So user wants to send a mail, the SMTP client program will ask the DNS client service, hey, come on here, get me the IP. So DNS now becomes a supporting program for all these application layer protocols. And DNS client will send a query to the nearest DNS server, which has the database, where it looks at the database. Okay, now wonderful.com, the answer is IP is 200.200.200.5. So that query, the client program has sent to the server, nearest server. That response comes back to the client, and the DNS client service returns back to the SMTP client. And once SMTP gets the IP address, then he can happily do his protocol functionality. He will connect, establish the TCP connection, and he will try to send the mail. Okay, so that's how it happens. So this program to work, it uses the help of DNS supporting program to get the IP address, and then it tries to execute its protocol functionality. Whether it is SMTP or whether it is FTP, FTP again, file transfer services. You're trying to upload and download files from Drive, right? Now, again, what is a Drive domain name? You do not know. It gets help of DNS client. DNS client sends a query. The response comes from the DNS server, and the client gets that. And the IP address is basically returned back to the FTP client. So, including for HTTP, right? So, name all your client server application layer protocols. You are holding domain name. It needs to use the domain name service. But here there is a question. What if the nearest DNS server, say at your ISPN, does not have the information of the domain name, because it's a distributed database, right? You can't have the entire information of all the domain names, what's the IP. So if you don't have the IP information for a domain name, what does this server do? How does this find out the answer and gives back to the client? There is where the resolution process, we will understand. Okay, we'll understand that shortly. So I'm going to take you now quickly. I was asking you some questions, sir. What is this dots, right? Why are you doing this? How are you assigning names? What is these domain types and stuff like that, right? You can assign names like how your parents assign name to you. I can assign a name to you. But then we see a lot of parents assigning names to their child, where a lot of duplicate names you see, right? So when you have a flat naming structure, say Jai Vignesh, how many Jai Vignesh are there in this world? I do not know. But obviously, yes, there are duplicates. Correct? So we how what is now the way that you're going to assign such a way it's a unique name assigned to a unique IP. This is what we need to do. So there should be a binding with the name that you're assigning to an IP, that such a way that the name is also unique across the globe. And that should be a distributed way of naming, and that should not be a centralized way that one authority controlling, the complete naming structure. So this is something which we will understand. So what is namespace? How much space or length that you can have when you assign your names? So here we have two concepts. One is you can either use a flat namespace, but as I told you, flat namespace like Jai Vignesh, website with Jai Vignesh, just a name like that. But there is no structure in that, right? And assigning flat names without any structure is going to be very, very difficult to control in a very large system like internet, because you need to avoid duplications, names, right, and confusions in handling this. And so the way that we're going to map an address to a unique name, we're going to divide it into paths. That's where the dots comes, as you see. So that kind of a namespace and naming structure, where you're going to allot space for each of the part of the labels of names that you have, is called hierarchical namespace. So the name is going to be divided into several parts. The first part may tell the nature of the organization, whether it's a commercial organization, whether it's an academic institution, whether it's a business firm, right? So depending upon the nature of the organization, you have the first part. Now in that first part, again, you decentralize. You try to now get a name based on the name that you want, right? Say as a company like CTS, right, wants to get a domain name, and it's a commercial company, say .com, right? So he tries to get from that authority one unique name. But then after he gets that, all the remaining parts, the prefixes, he can assign. So you can decentralize the naming now, but at every level you ensure that there is uniqueness, right? So that's something which the hierarchical namespacing actually comes to do, which basically means you're trying to decentralize the complete name assigning, where one central authority will only assign the part of the name, which basically means the name of the organization. Rest part, you can give the control to the organization itself. Organization can go on to prefix, like how IIT Madras basically tries to prefix having get the domain name from the organization, right? So from the central authority, they can prefix and map to whatever number of servers that you're hosting, service that you're hosting, they can try to map it. So they need to be not worry about duplicates, even if CSC comes multiple times in different cases. But the entire unique name, it becomes unique, right? So the complete domain name that you see. Okay, so I hope you're able to understand this. So let me answer the question now. How many levels you can have? How many dots you can have? So I hope you understand now the domain name of the dots that you're having. The names now let us represent it in a structure. That structure, we're going to call it as an inverted tree structure. What do you mean by inverted tree? Sir, okay, sir, www.google.com, right? So as you go to the top, right? Now the top of the tree is called as a root node, right? Now root node is just the beginning point. It's every node you're going to give a label name. So say this is the parent and these are the child's first level. The first part, right? The type of organization. Second part, the name of the organization. So it goes like that, right? So now what I need to assign is, okay, the childs of this particular parent, these names should be unique. Now, this guy in turn has his styles, right? Those style names should be unique in that level. So you're now trying to decentralize stuff and you're trying to take it. So this is called the inverted tree structure. Okay, if you're still confused, I'll try to take it further now. So what are we trying to do now is every node that you see here, which starts from the root, every node here, you're going to assign a label name, right? So com is one label name, edu is one label name, org is another label name. So all these top level nodes you look at, every node has a label name. And if you go and look at the specs of that, the number of characters in every node labels could be a max of 63 characters. Okay, so look at how much is the bound that is defined. But then the root node does not have any label. It's a null value. It's a null label. Okay, but then let's get on. Now under edu, you are, as an organization, education organization, you want to get a name. You go get to that authority and then try to get a domain name which is unique, which means the child node that you have, say VIT, right, should be unique. right? Someone has VIIT, that's fine. But then the idea now is the child nodes should be unique, right? So that's how the decentralizing happens. So DNS requires that the children of the node have different labels, right? Or unique names. But then it goes on, right? So I'm going to now take it forward. What do you, this inverted tree structure, right? So let's now look at this. I showed you now the first top level is the type of the organization. Second level comes the name of the organization that comes in. So ultimately, say we have a university which has its own website hosted and they've got an IP and they're trying to now map a domain name. So they go to the central authority of the EDU domain and try to acquire a name for their university. So root starts with the root. EDU is the level 2 organization type. And then in that, I'm trying to get a child name, which is of my organization name. And then I try to prefix my labels depending upon how many sites I want to host, right? I could have my labels. So now this inverted tree structure. So ultimately, your website or domain name is going to be from the bottom to the top. Every label you need to separate it by a dot. So ultimately, now the name will become acomputer.bdepartment.topuniversity.edu, and then you end with the root. Ideally, this you don't look at this. You only type google.com, vat.ac.in. The in is basically the top level node. But then you terminate with the null label. Null label is nothing, which basically means after that dot nothing, right? So this is where you're terminating. Okay, but we are not really looking at all these names, but that entire name, including the terminating at the root node, which is a null label, so it ends with a dot. Okay, so that kind of naming is actually called as, so that's your complete name, complete domain name, which is a unique name. And such domain name is actually called as fully qualified domain name, FQDN. I'm sorry, are you there? All of you are listening. I'm just going on. How many are there?
Yes, sir.
Okay, good. So that's actually called as fully qualified domain name. So you go on from the bottom to reach to the top and you terminate your label by a null string. So that's your full name. And ideally what happens is the DNS server can only match the fully qualified domain name to an IP address. But we don't type the fully qualified domain name. We only type partial names, right? Which means we don't reach out to the root, right? I could just have 2 labels or 3 labels and I can still expect my DNS client to suffix all the remaining parts till the root. And then the resolver, which basically is a DNS server, will try to find out what is the IP map to the fully qualified domain name. So these are all the internals that are happening, but I would just want you to understand now that you can have, now please understand, I'm not still completed the answer. I said every label can be 63 characters at every level, and how many levels you can have max is 128 levels you can have max, which basically means level 0 is the root, level 1, level 2, like that, 128 levels you can have. So if you look at the longest domain name that you can have, look at how many dots you can have if you have, but anyway, it's not typically used because it's all prefixes that you keep adding, right? But you can still go on. Ideally, the framework tells you can go till 128 levels, right? Interesting, right? So that's how DNS basically works. So these are some examples of fully qualified domain name where it all terminates with the root node, root label, which is a null string. But these are partially qualified, so you don't do that, but you expect your DNS client to basically add all this. But anyway, having understood this, I think we'll get back to now how the name resolution happens. So ideally now there's going to be a lot of DNS servers which are going to have authority over controlling how much domain names that I can have for a particular zone and stuff like that. So how is this resolver going to work? That alone we will look at, and we will try to complete the DNS part. But one interesting thing, I just want to show you what are all the domain types you're not aware of. So look at this. I think edu you're aware of, GOE you're aware of, commercial you're aware of. There's something called .biz. How many are aware of .biz sites? Just go and browse it. There's something called Aero. So Aero is basically for airlines and aerospace companies. So this is a domain type: business firms, commercial, co-op business, educational institutions, government institutions. Info sites .info. I think you would have seen that. International military groups as .mil as the organization type. Museum. You can have your own personal names, right? All these orgs, non-profit organizations. So there are different authorities to manage different on the domain. organization name that you want, you go to the respective authority and try to get a unique domain name. So if you're hosting a website, yes, you have a lot of websites to basically acquire a domain name depending on the type of the domain that you want. Okay, now I'll just take a couple of minutes and then try to tell you how DNS try to resolve if it does not has the answer. Okay, so here I hope you would have been writing a lot of algorithms in your Python and Java or whatever language that you take. But let me ask you some fundamental questions now. How many are aware of recursive algorithm? Anyone? You know how recursive algorithm works, right? It keeps executing, the same function again and again with till it reaches the base condition, right? So recursively it tries to do. So here again, let's talk resolutions from two aspects. Now, what is mean by resolution? Now, ultimately, DNS client wants to find out what is the IP address that is mapped to the corresponding domain name. So the resolver or the DNS client will access the closest DNS server to find out, hey, tell me what is the answer. If that DNS server does not has the answer because it's a distributed database, right? So how does it tries to find the answer? So here there are two ways that the resolution happens. One is called recursive resolution, and other type of resolution is called iterative resolution. So these are the two ways in which your resolver or the client which tries to find out the answer for the query. If the server is not able to closest DNS server is not able to provide the answer, how does it tries to find the answer and gives you, right? So here if you look at in recursive resolution, the client sends a query to the nearest DNS server, but that does not have the answer. So he tries to reach out to his parent, say, server, and tries to query, right, and get the answer. But say he also does not have the answer. So he in turn tries to reach out to the root DNS servers, and this keeps going on to this DNS server, which basically has the mapping of the particular information, which is the IP. So once the proper DNS server that has the answer, right, returns that answer to the previous parent which queried, and this keeps going on. So this is called recursive, right? So this keeps going to the parent who asked, and this keeps going to the parent who asked, and this keeps going to the local DNS server, and that guy finally returns the answer. So ideally, they are trying to resolve recursively to find out the final answer and get back and send it back to the client. Now, once this closest DNS server finds out recursively and gets to know what is the IP map to a domain name, next time he doesn't need to follow this procedure because he now has understood, say for some website, you don't know what is the IP, your DNS server does not know, he recursively tries to find the answer and then he cache it in its database so that next time when you're trying to reach out, in fact, your client can also cache it so that you can try to basically use that IP address for the future. You don't need to again, do this resolution process. But caching a particular entry is also limited in time because you know that domain names can change, the IP address can change and all that. So we ideally have again a timer, a TTL value, which is how long it could be active. So this is called recursive resolution, where the resolver expects the server to supply the final answer, right? If that DNS server is authority of the complete domain, he has the answer, it's fine. If it not, it needs to query to another server and wait for the response. Otherwise, again, query to another server. So it keeps going on till it reaches to the closest server, local server, which sends the final answer. So this is called recursively trying to find out the solution. So these are the examples in a way you can look at it. How does the answer comes? But then the contrast of this is iterative resolution. This is slightly a higher overhead because the DNS client has to break the answer, has to break his head to get the answer. Say, for example, the DNS client first contacts the nearest DNS server and tries to get the answer. But if he does not have the lookup information of what's the IP, he says, hey, come on here, I don't have the answer. But I'll give you the IP of the DNS server or my parent DNS server, who you can reach out and try to see if you get the answer. So client, okay, say, okay, tell me who's the IP of the DNS server I need to contact. So the client now, so this guy says, go contact edu domain DNS server. So client goes and sends a query again, and now edu says, hey, I don't have the answer. I don't have it in my database. You try contacting this particular server. He gives the IP. So every iteration, those who don't have the answer will only return to whom they can contact to see possibly if they can get the answer. And this keeps going on iteratively till he gets a final answer from the corresponding DNS server who basically holds that information. So this is how the information would be distributed. But once you get the answer, you can basically cache it and then you basically try to get it. I hope you're able to understand what I'm trying to say. So having said, there's a lot of caching that happens, and this kind of resolution is not going to happen every time for the same domain name. So that's again another point that you guys need to note down. I'll end the DNS discussion. I'm sorry, I'm going to take another 10 minutes with your patience. I hope you don't mind. So I'm going to end the DNS by telling DNS basically uses an underlying transport layer protocol. As you know, application layer protocols needs to take the help of the transport protocol to deliver their request, to deliver the query, get the response. HTTP used to TCP to set up the connection and get the web pages or whatever it is, right? Similarly, DNS ultimately sends a very short query. Hey, what is this IP for this domain name? Can me, right? I'm sending a query and I want the response quickly. So it's a very short message which can be fitted in a UDP datagram itself, which is a connectionless service. And so UDP will try to transport that to the DNS server and get the response and then try to do, right? So that's DNS ideally uses UDP, right? And the DNS server service that's running listens on a default port number 53, which is a well-known port number. You don't need to remember all this, but just for the information. But don't get confused. DNS also uses TCP only for the case when you have this database where you need to take a backup. All the DNS servers having a big database, say for example. So it's not just you have one DNS server. There's something I'm not sure whether you've seen in your configured DNS server settings in your system. Anyone have you done? You will be basically looking at primary DNS server, secondary DNS server, and stuff like that. But then the idea now is you have to take a backup of your zone database. And so for taking a backup of a complete database, DNS basically uses TCP as the underlying protocol. Anyway, these are something on DNS. I hope you get an idea of some of the questions that we try to ask initially. If that's interesting, yes, that should be the end of DNS for you. Okay, how many are clear with this so far? Can you raise your hands? How many are still there? Will you permit me for another 10 minutes where I'll take up another interesting protocol? But let me try to see if I can make it interesting for you. So the next protocol is what is about understanding SMTP, not just SMTP, but two other protocols, right? SMTP, which stands for, can anyone tell me what is SMTP? Okay, I'm not sure how many are there. So SMTP
Simple
stands
mail
for
transfer.
Simple Mail Transfer Protocol. Very good. And then there's another protocol. I'm not sure. Okay, you guys have all been using web, Gmail, web clients, which basically you log into Gmail and then I'm not sure how many have accessed desktop email clients. Have anyone used Outlook? Are you aware of any other mail clients that you have a desktop version installed and then you try to sync your mailbox, you try to read mails, send mails? Anyone? Okay. So anyway, so let's look at this now. If you have done that, then you would have known some other acronyms or protocols that comes in, which is one is called POP. What is POP? POP is called Post Office Protocol. SMTP stands for Simple Mail Transfer Protocol. So what am I going to discuss now? I'm going to discuss about email, which is electronic mail. I think it's going to be interesting in the sense that if you can go back to way back where we were transitioning from an era of postal system, right? A postal mail to an email. Email, electronic mail, basically is just an inspiration of how postal system works, right? So what are you doing in an email? Initially, the mail was just sending text messages, right? Can we take up the same characters? Alice say wants to send mail to Bob, right? This is not an instant chat, right? Alice is sending a mail to Bob, right? And Bob can open his mail client or access Gmail or whatever it is whenever he wants, and he can read the mail. Okay, so this is the idea, right? So you need to send a mail, and your mail is basically your message that needs to be transferred to Bob. So that message needs to be transferred to Bob, and Bob needs to read that. So that's the ultimate thing. You want to transfer your information, and now these days you're trying to transfer your mail, which is having attachments, which is having multimedia contents, not just files, but all video and stuff like that, right? So we are able to do all that. We are able to transfer the data as a mail attachment, right? But then you need a mailbox. Now, this mailbox is a storage space that's given where you're assigned a private. Just imagine like you have a folder space in this system, in this computer, and in that folder space you have all your files or mail stored, right? So it's like a special private file which is assigned to you, mailbox that's residing in a server, and you are trying to store your information there, and you want to read it, right? So whatever is there. So how does postal system basically works? Now, I want to deliver my letter or information to someone. I write in the envelope the to address, the from address. So similarly, when you're sending an email, you put the to address, right? And which has basically a format, the mailbox jvignesh.t at the mail server domain name. So at vit.student.ac.in, which is again part of your VIT student ac.in mail server, Gmail account, right? So your mailbox is going to reside there. Like that, everyone has mailboxes. So I want to send to some X person, say Bob, and I'm sending a mail to Bob that has to get stored in that server, right? So now similarly, let's look at this. I want to deliver the letter, right? So what do I do? Right? I need some services, right? So first, my letter has been put in an envelope, and I'm going to drop it in my nearest post office, right? I'm not sure. All of you know post office, right? So if you've seen your post office, okay, you go and drop the letter, and then you rely on some postal service where they are going to transfer that letter and take it to the corresponding destination place, post office, right? And yeah, where that letter has to go. Okay, so it reaches through some carrier. Okay, you're transferring that message, the letter, and reaching out to the destination location postal office. And then there is a guy, okay, who's an employee in the postman that we call. He goes on and looks at all the letters that has come. He takes it and comes to your home. And in your home, you have a post box. He puts that letter in your post box and he goes off. So there is a service which transferring from that destination post office to your home, right? Post box. You residing in your home can come anytime and open the post box and take the letter. So as a recipient of an email, I can read the mail at any time when I wanted to access my mail. But the mail has already come, right? It's already stored. That you just have to pull from that post box, right, and read the mail, right? So there's going to be two protocols that's going to be involved. One is called the SMTP, which is called Simple Mail Transfer Protocol. Simple Mail Transfer Protocol. You're trying to transfer your message or the mail, right, to the destination mail server where the recipient mailbox is residing. Okay, so I'm going to use SMTP protocol to transfer the mail such a way it gets delivered to the destination or the recipient mail server and his mailbox. And it's going to sit there. Now, the Bob who opens his mail client at that time, I'm going to have another protocol, like how I go open my post box and pull the letter out of the box. I'm going to have another protocol which is called Post Office Protocol, POP, which is a pull protocol. SMTP is a push protocol. You push the message, right, to the destination mail server. And then the Post Office Protocol is the Bob, the recipient who wants to read the mail, is going to use this push-pull protocol to pull the message from the mailbox and read it. Okay, so this is the idea. I'm okay. I hope you're able to understand what I'm trying to convey by taking this analogy of postal system and trying to translate this. Okay, so I think you're able to understand this, but it is not the traditional kind of a client server architecture that you're looking at. Now, what do you mean by client server? Client requests a service, server should be running 24/7. So whenever client requests, right, the server should be able to provide the response. But that is not the case here. Here we have two clients, Alays and Bob's, who want to send and receive mails. But you can't expect Bob to immediately send you a response. Bob, at any time, he can switch off his system and he can open his system at any time and try to get the mail. So the mail is going to be sent. It's a one-way transaction. But then whenever Bob turns on, so he basically has to pull from his mailbox and read out what is there. That's how it works, right? So which basically means two clients are going to work. But then it's still a client-server architecture. In fact, if you go look at it, there are going to be intermediate servers, which are mail servers, say from yahoo.com to gmail.com, right? I want to transfer a mail. So from one mail server, it has to be transferred to his mail server and his mailbox. And from there, I need to read it out. So I'm going to have SMTP protocol, which is going to help me to transfer this message from one mail server to another mail server. And I'm going to have the post office protocol, POP, which is going to pull the message mail from the recipient mail server mailbox. How many are able to understand what I'm trying to say? Are you able to, think logically and also understand it from the protocol? Because there's a lot stuff there, but I'm not going to complicate stuff. I just want you guys, if you're able to understand that, I'll be happy to this. So there's going to be three agents. Don't get confused what an agent is. Agent is again a program, right, which is basically trying to do a part of the process. So user agent is one component. MTA, or mail transfer agent, is another component. Mail access agent is another component. Transferring mail, you need a service. Accessing the mail or accessing the message, to access the message, you need another service. So what is an user agent? Like say, suppose I have the Gmail is a web client program, right? But then you're having desktop client programs, say for example, like Outlook or Eudora and all this, right? It has a GUI, nice GUI. But there were days where it was all command line. I'm not sure how many have really used some commands in Linux where you can use mail command. You need to type. If you want to reply, you need to type R and then do. So everything is like, command driven itself. Then what is these protocols trying to do, right? The service trying to do is send one command, get a response. I'm sending the to address. Okay, fine. The response back. Sending the from address, sending the subject and all that, right? So everything is being sent and you get the response. So there's going to be this protocol which is going to transfer everything, get the response, see everything is fine. If the response codes, status codes are improper, then you are going to do. So all these protocols which are transferring contents is going to do all that work. So user agent is going to be the program at the client side or the user side using your, say, desktop mail clients or your web clients, right? Where you click on the buttons, send mail, right? Compose a message and all that, right? So that's the user agent. But then you have to transfer your message, right? Across the internet. You're going to use this mail transfer agent, which is, again, if you go and look at the architecture, I'm just going to show the architecture slightly so that you can understand what's basically happening. So the client side, okay, I'll show you another picture. Understand what's happening. So the client side, okay, you have the user agent. As I told you, these are two clients. But then if you look at, there are three client server programs that are basically going to work. One is the MTA client and MTA server. This is one thing. And then from one mail server to another mail server, right? That's going to be another client server program. And then Bob, who at any time wants to read the mail, there's going to be another client server program. So two clients wants to talk, it's going to be three client server programs that's actually going to interact. Okay, so that's how the beauty is. So the MTA is a message transfer client, right, which is using SMTP protocol, which actually transfers your mail. So it sets up a SMTP, simple mail transfer protocol, sets up a TCP connection to your mail server and tries to transfer your mail, which has to be delivered to the recipient mailbox. So from your current local mail server, it's going to be spool, which means the mail content is going to be placed on queue. And then again, you have another SMTP protocol where it's going to set up the connection to the destination mail server, right? And then going to transfer that mail to the destination mail server where it's going to reside in its mailbox. So this will happily sit there. The mail message that you have will go and sit in his recipient mailbox. So you have two SMTP functionalities, right? From your user agent to your MTA server, your local mail server, via the MTA client, MTA server will set up a TCP connection. So SMTP is basically going to use TCP as the underlying transfer protocol to transfer it to the local mail server. And then from there to the remote mail server where the recipient mailbox is, right? Again, another SMTP protocol TCP connection is established. So the mail message gets sit in his mailbox. Now, Bob at any time opens his mail client and uses a pull protocol. So this is pushing your message to the corresponding mailbox. SMTP is a push protocol. Bob basically uses another protocol called post office protocol. So this is called message access agent. So the agent is a service which is trying to pull the protocol from the server is basically trying to pull the protocol from the mailbox and then give it to the user agent. So the MMA client, basically the client server uses POP. And in fact, the exact version is POP version 3. Post office protocol is a pull protocol. SMTP protocol is a push protocol. This is what I want you guys to understand. If you're able to understand this scenario to some extent, this flow is basically around 9 steps that get involved in order for a user to send a mail and Bob to read that. So this 9 steps goes in this flow. And I think I've already explained to you how an email address is. So I'm not going to get into this. You don't need to bog your head, sir. What is all this? The idea now is okay. So you have your, user Alice wants to send a message mail to Bob, but then ultimately what happens is that the SMTP protocol, message transfer agent, the SMTP client sets up a TCP connection with a local mail server, right? So the TCP handshake happens, and then your data transfer happens where your envelope, like how you have your mail from to, for everything is sent individually, like a command, and then the response comes. Okay, this mail is coming from this, it has to go to this. Okay, next, what is the data for, what is the subject? And then what is your body? What is your attachment? So everything that you're sending, you expect a response when you set up a connection. And finally, once you're done, the TCP, as you know, it's a reliable protocol, right? It closes the connection, terminates. Now your mail is now residing in your local mail server. So from there, again, another connection you need to establish to your destination mail server, and it has to get delivered in the mailbox. So SMTP involves in two stages. The first and the second stage mail delivery uses SMTP, which is a push protocol, right? So the data is getting pushed from the client to the server. The third stage is where the client or the recipient needs to pull the message from the server, which is a protocol. So there are two protocols here. In fact, pull protocols. One is called Post Office Protocol, POP version 3, right? Another one is called Internet Mail Access Protocol, version 4, IMAP 4. I'm not going to get into the IMAP 4 is much more powerful and complex than POP 3, but these are all pull protocols. It tries to, any recipient wants to read mails, right? You're downloading mails in your client, right? You're opening your Gmail and you go refresh, or automatically there's a timer which tells you how many mails have been read. It is pulling it from its mailbox. That protocol that helps to retrieve that mails from the mailbox is your POP protocol. So I'll just show you what POP basically does in terms of version 3. So Bob, when he opens his client, user agent, right? There is this POP protocol, which is basically a series of command response that happens. See, ultimately, you have to get authenticated to access your mailbox from the mail server. So you send your username, you type your username, right? Once your username goes, the POP server, that is your message access server, that's says okay, and then you send your password, it says okay, and then you say, come on, list me all the mails. That's again another command. List all the mails that are new and all that. So what are all the email numbers, the size, everything gets retrieved. And every individual mails are getting retrieved one by one, right? The list of all the new emails that you have to read. So this is a series of commands and response that happens when a user wants to download the email from the mailbox that is residing on the mail server on its client that he's using via the browser client or via the desktop client. So this again, the POP protocol sets up a TCP connection to pull the message, right, or download the email that's residing in the mailbox of a server. So once that connection is established, it's all a series of commands that you see here. It sends its username, password, and then they can list and download the mail messages one by one. So it's downloading using the POP incoming, mail server. Similarly, IMAP also does this, but it's more powerful and complex. For example, POP does not allow you to check the email contents before you download the complete mail. Whereas IMAP 4, you can basically check your email header prior to downloading it. So how does this process happens? It varies, but I'm not going to get into the details of this. So ideally, if you look at, it's all an inspiration from your postal system, right? Look at how electronically they have now come up with lots of commands, setting up a connection, trying to deliver. So all your transport layer, network layer, data link layer, physical layer is trying to help and reach out to that server, trying to transfer that. So it's ultimately how beautifully now we are, sending mails without knowing what's internally happening, right? So you can go find out more if you're more interested. But I think I've covered you the fundamentals. How many are clear with some idea of how email works now, how DNS works, how HTTP works, right? So I've taken you three protocols.